everyone, welcome back to another video on quadratics. Today we're going to be talking about Vietas formulas, and that is the second way to graph a quadratic equation. So let's get started. Now, why do we need Vietas formulas? Well, the main thing is the previous method we discussed in the video where you find a bunch of points and graph it, it doesn't always work. So if you have extremely complicated numbers, let me give you an arbitrary example. Let's say you have y equals 456x squared minus 3659x plus 20,558. Now, clearly, if you have such a complicated one like this, you can't just keep graphing points. That'll take forever and ever, and it's too tedious with such big numbers. So what we do instead is use a trick and find three major points on the graph and graph those, which will give you the entire graph easily. And this method works best because it's also very efficient and you don't really have to waste time drawing out the graph, especially if you're into competitions like AMC 8 or AMC 10, Math League, and yeah, you really want Vietas formulas over that other method. Okay, so I'm going to start off with a general example and then give you a example with numbers. Now, let's start off with the standard form of a quadratic equation. That is y equals ax squared plus bx plus c. So that right there is the standard form. Now, Vietas formulas has something to do with the roots. And with the roots, you can write quadratic equations in another way. So the same quadratic equation we're going to write this way. Y equals a into x minus r1 into x minus r2, where r1 and r2 are the roots. And this form is known as the factored form. So here the roots, or if you don't know what roots are basically the x-intercepts of the graph. The three common names are roots, zeros, and x-intercepts. They all mean the same thing. So the roots here are x equals r1 and r2. Okay, now let's see what we get when we expand that. We get a into x minus r1 into x minus r2 is equal to a into x into x minus r2. So basically, we're just applying the distributive property here. Yeah, it's pretty simple, really. All we're doing is expanding this and seeing what we get. Now all we're going to do is just expand it again. So this term and this term needs to be expanded, so we're going to go ahead and do that. And that'll give us a into x squared minus x times r2 minus x times r1. This is actually r1 times x minus r1 times x, but you can multiply numbers in either way, so it's x times r1 and whoops, plus r1 times r2. Okay, and finally we can distribute the a across all the terms. Actually, before we do that, a simpler way would be to combine these two forms. Because you see the x here and x here, we want to get it into the form ax squared plus bx plus c, where there's a x squared, x, and a constant term. So since we have two x terms, let's just combine it. That'll give us a into x squared minus r2 plus r1 x plus r1 times r2. All we did there was factor out the r1 times r2 and the negative sign over here and write it as an x term, as one x term. And now we're going to just distribute it, and this will give us ax squared minus a into r1 plus r2. Now I just rewrote r2 plus r1 and r1 plus r2 is equivalent by the commutative property. You can add numbers in any order. And r1, not there, we were missing an a into r1 into r2. Okay. Now, since we specified that these two quadratics are equal, we made sure in the beginning to say that these two quadratics are equal, which means this expression we got should be equal to ax squared plus bx plus c, right? And if they are equal, it means all their coefficients should match up. And this is the reason why I wanted to combine the x terms, because their coefficients should match up. In other words, the coefficient of this x term here is a, and this x term here is a, the coefficients, and they match up. And that's good. The coefficient of the sorry, this is the x squared term. The coefficient of the x term now is b, and here the coefficient of the x term is negative a into r1 plus r2. Since they're the same quadratic, these two coefficients must be equal, and will give us our first equation. Negative a into r1 plus r2 equals b. And finally, the constant term here is c, the constant term here is a into r1 into r2, and again, they're the same quadratic, so they should be equal, and that'll give us our second equation. A times r1 times r2 equals c. Now, I want to do something to this first equation so that it'll get rid of this annoying a on the left side. Instead, all we want with Vietas formulas is to leave us with the roots, just the roots on the left side. We want to solve for the roots. So how can we do that? Well, we can divide both sides by negative a. Doing that will give us r1 plus r2 equals negative b over a, right? And the next one here, we can do the same thing here, but we want r1 times r2, and there's no negative sign here. So all I'm going to do is just divide by a and not negative a this time. And that'll give us r1 times r2 equals c over a. And there you have it. That right there is Vietas formulas. Now, why is this formula so helpful? Well, let me show you why. Before I start, I'm going to point out the three major points we're going to be working with on the graph of a parabola. So I'm quickly going to draw a random graph here. So let's say this is our parabola, right? That's our parabola. Now, in this parabola, there's the x-axis, right? And there's the y. The point where it intersects the x-axis. So this point and that point right there. Actually, let me change the color. Okay, I hope that's better. These 2 points are known as the x-intercepts, meaning this is where they cross the x-axis. And these are also the roots of the quadratic equation, or the zeros. So all those three things mean the same things. Okay, so these are the x-intercepts, and a property of the x-intercept is that wherever the x-intercept is, the y-coordinate is always 0. And you can see that this point is 0, 0, or the origin, and the y-coordinate is 0 all throughout the x-axis. So the point of a quadratic equation is if you use a factored form, a into x minus r1 into x minus r2. If you want to find r1 and r2, then we don't know the x coordinates yet, because that's what we're trying to find. Actually, we're trying to find x here when we have the roots, but we do know the y coordinate when that would be 0, right? So this equation is what we use to solve for the x-intercepts and the zeros, or x-intercepts or zeros, or roots. Okay, the third point is this bottommost point on the parabola right here, vertex. This point is called the vertex of the parabola. It's on an upward opening parabola. It's where it achieves the minimum value of the parabola. There's no other value on the graph that can be lower than this point on this entire U. Now, on a downward opening parabola like this, the vertex would be the maximum point, but that's different. Okay, so now, a neat property about the vertex is the line where the vertex is, if you were to draw a line directly above, then the parabola is always symmetric around that line, about that line, which means that line basically acts like a mirror for both the sides. And you know what that means? It means wherever that line hits the x-axis right there, that point is exactly in between the two x-intercepts. And we're going to be using that fact right now. Okay, so let me actually show you with an example that we used last time. Y equals x squared plus x minus 6. This is the example we used last time. And let me show you what we can do with this one. Now, let's say the roots of this equation are s1 and s2. X equals s1 and s2 are the roots. We want to find that the sum of s1, the product of s1 and s2, needs to be equal to negative 6. And how do we get that? Well, we just apply Vietas formulas, this formula right here, that the product needs to be negative 6, right? And the reason for that is I'm just going to write it down. S1 times S2 equals, it looks like a Z. S1 times S2 equals C over A. And here C is negative 6, right? Since the coefficient here is 1 of the x squared term, A is 1. The coefficient here is 1, so B is 1. And the constant term is negative 6, so C is negative 6. So then we have negative 6 over 1, which is negative 6. And that's why the product of the roots is negative 6. Now, what two integers can we find that multiply out to be negative 6? We can see 1 times negative 6, negative 1 times 6, 2 times negative 3, negative 2 times 3. Those are the only four. Now we'll use the second formula. That's the sum of the roots. We have that the sum of the roots is equal to s1 plus s2 is equal to negative b over a. In this case, b is 1 and a is 1. So this is equal to negative 1 over 1, or just negative 1. Now, which of these four actually sum out to be negative 1? In this first one, 1 plus, actually, let me write it down. In this first one right here, 1 plus negative 6 is negative 5, which is not equal to negative 1. So this one does not work. Negative 1 plus 6, negative 1 plus 6 is 5, which is again not negative 1. So this is not the one we're looking for. And 2 plus negative 3. 2 plus negative 3 is 2 minus 3, which is negative 1. So this one works. This one's a valid choice. And finally, we'll test out the last one, negative 2 plus 3, which is 1. And that is not equal to negative 1. All right. We've already found our solutions here, so this means that we have already found our roots. And they would be s1 equals 2 and s2 equals negative 3. And there you have it. So let's graph this. I'm going to draw the axes, and if you watched the last video, you'd notice that these numbers are somewhat interesting. In fact, we actually found these on the graph earlier in the previous video. And let me show you exactly where we found it. Since these are the roots, we already know at these points the y-coordinate is 0. So the roots are 2, 0 and negative 3, 0. 2, 0 is over there. Negative 3, 0 is right here. And there you have it. Those are exactly the x-intercepts we found in the previous video. And that can't be a coincidence, right? So that's proof to you that Vietas formulas actually works, and it's not just something I'm making up to. Yeah. Now we can go about finding the vertex. Let's use that midpoint thing I was talking about. The midpoint would estimate to be about there. That's the midpoint. And how do you find the point exactly in between? Well, to find the x, we already know the y-coordinate is 0 because that's on the x-axis. And to find the x-coordinate, we simply take the average of these two. And that's just like taking two odd numbers and taking their mean, which is just the sum of them divided by 2. That gives us 2 plus negative 3 over 2, or negative 1/2. And that's the x-coordinate. So this point is negative 1/2, comma 0. Now we want to find where the vertex is located when x equals negative 1/2, comma 0. So it's obviously going to be on this line, right? It's going to be somewhere on this line. Where is that? Well, how can we find the y-coordinate when we're already given the x-coordinate? We saw that in the last video. It's easy. All we're going to do is let x equal negative 1/2, and we can plug it into the equation. Just like what we did before. When y equals x squared plus x minus 6, everywhere we see an x, we're going to replace it with negative 2 or negative 1/2, and it'll get us y equals negative 1/2 squared plus negative 1/2 minus 6. And you can solve this, and it'll turn out to be negative 25 over 4. I like it in improper fraction, but if you want to visualize it better and see where it would be better, then read negative 6 1/4. All right, now we know that negative 6 is about here. This is negative 6. So 1/4 down would be right about there. And that's the last point we need to complete our graph. Now 3 points define a parabola. So we can quickly start graphing this and connecting those 3 points. All right, so that was pretty simple, right? It was a bit lengthy, but if you get the hang of it, you can do it really fast. And this formula is extremely useful to save time, and also it's very efficient, meaning you can, for example, if you in real life when you actually go out and do work in your field of choice, you won't have time to you're going to have like way more complicated equations than this. It's not going to be just x squared plus x minus 6. It'll be even worse than the equation I showed you in the beginning. So obviously with that equation, you won't have time to sit around graphing points and then try to connect them. You'll have to use a trick approach like this one. All right, so that was it about Vietas formulas. I really hope you enjoyed the video, and go ahead and try out a lot of examples just like this with your own quadratic equations, or use some problems that people give you, or yeah. So I hope you enjoyed, and I hope you started developing a sort of liking for quadratics in math, and if you did, that's great. Thank you so much for listening to this video and watching through the entire thing, and please subscribe to my channel and give a huge like on this video. Thank you, and see you next time.